Right, a special relationship. So there's a special three-way relationship between voltage, current, and resistance. So yeah, it's a bit like the fire triangle. I don't know if you remember that from school, but for a fire to work, it needs three things. It needs heat, fuel, and oxygen. And taking one away has an effect on the other two. So with a fire, if you've got a lot of oxygen, but no heat and no fuel, well, you can't get the fire to work. And whatever you do to any of these three parts here has a knock-on effect on the other two, and the fire in total. And electricity has a similar sort of thing. So voltage, current, and resistance, they relate to each other closely. So this relationship was documented by a clever German lad called George Simon Ohm, and he written a book called Die Galbanichkette Mathematisch Bebetet. And the primary rules which govern electrics, or electronics, which he formulated became known as Ohm's law. And this is Ohm's law. Ohm's law states that electrical current is proportional to voltage and inversely proportional to resistance. And you can use this triangle here to calculate things. So if we had, let's say voltage is 12 volts, and amperage, I said it earlier, amperage is usually denoted with an I symbol. So let's say voltage is 12 volts and I was 1 amp. You could do 12 volts divided by 1 equals 12. So you'd know that ohms, or resistance, would be 12 ohms. And this works in all sorts of different ways. So if you got 12 ohms and you've got 1 amp, 1 multiplied by 12 is 12 volts. So yeah, it works like that. So finally, and very briefly, how do flowing electrons power things? So you can get electrons flowing into devices, but how does that power anything? Well, yeah, it depends on what you're trying to power, but this is a very difficult subject, really. So heat. If we increase resistance, which we went through before, if you increase resistance in a wire whilst maintaining the voltage and current, electrons struggle to squeeze through and they collide. And when they collide, they release energy in the form of heat. So you may have noticed, with electric radiators or a toaster or something like that, well, a lot of current is forced through a thin wire. And if you actually look into a toaster, you can see that there's thin wires. And what happens is the electrons collide with nucleus in atoms and probably one or two other different things. And when they do that, they lose their energy in the form of heat. And that's how you can get heat from electricity. Light. So when we shock electrons in an atom, they get excited and they can become dislodged from the nucleus of the atom, and the nucleus of the atom draws them back. But when they get shocked, they can sometimes gain energy, but the nucleus doesn't let them come too close again, even though it attracts it with that much energy. So what happens is the electron gives off its energy and then becomes close to the nucleus again. And when it gives off that energy, it's given off in the form of photons, which is light. And kinetic energy, I've not looked into that. I didn't think it was that important for the purpose of this this presentation. So you can find out that yourself. So to summarise, what is electricity? So electricity is the flowing of electrons across a conductor. So how do we get electrons to flow? To get electrons to flow, you need to apply enough pressure, and pressure is maintained in volts. So if there's a potential difference or a voltage, electrons could potentially flow. What is resistance? So resistance is how much a material resists the flow of electrons, and that's measured in ohms. So if you remember the little diagram, if a nucleus of an atom holds its electrons very close to itself, it has a strong grip on them, then those electrons are not susceptible to being moved or pushed out of the nucleus's control, if you like, into another atom. So in that case, electricity is not able to flow because there will be too much resistance. In other words, the material doesn't have good conductivity, too much resistance, and it hinders the flow of electricity. What is current? Current is the amount of electrons flowing in a certain area within a given time scale, and that's measured in amps. It's basically the amount of electrons flowing. And then a special relationship, volts, amps, and ohms all relate to each other. So if you know two of them, you can work out the other. Ohm's law. Ohm's law is a set of formulae to help with electronics. I'm sure probably millions of people use this law every day to help with our electronics, and it's very useful. And how do electrons power things? Well, colliding them with things under pressure and forcing them through resistive materials produces heat, and exciting them can produce light. As for kinetic energy, you can find that one out yourself. And we're done. So once again, thank you for watching, and I hope you enjoyed the video. Thanks, bye!